I'm just going to write down what you're looking for. So if you're solving a quadratic, there's a bunch of different methods. We've just done one so far, which is factoring. Another option is graphing. This is not always your best option, and we'll explain that in a second. But to solve a quadratic by graphing, all you're looking for is basically you'll have, and maybe you would have it in standard form or vertex form, but basically you graph the related quadratic. So maybe your equation is 0. You'd have stuff filled in for the a, b, and c for ax squared plus bx plus c. You graph the related function, which would mean like we would graph y equals whatever we had here. What you're looking for in this situation, when y equals 0, what you're going to be looking for is where the graph crosses or touches the x-axis, which will just be, I'm going to put x-intercepts. All right, so ultimately what you're looking for, where the graph crosses, or in some cases it might just touch it and go back, or touches the x-axis. That's going to be the x value that would be your 0 or your root. A lot of the questions will have 2, occasionally they'll have 1. Sometimes they might not touch the x-axis. We're going to talk about that here in a second. But basically, if you're solving by graphing, you're trying to make y 0. Where that happens is across the x-axis. So it would be where the graph crosses, or like I said, maybe it just touches the x-axis. So for these first 3 questions, I just have a graph already to go for you. So I'm just going to scooch this up just a little tiny bit. So you don't have to highlight this, but I'm going to on my paper. I'm literally just, the y value will be 0. So I'm literally just looking for the x value where the parabola goes through or just touches the x-axis. So literally you're just going to pick numbers off the graph here. So like for this first one, I am going through the x-axis at 4 and 8. So those would be my 2 zeros. I know I don't have an equation typed in here for this, but if we had an equation, we could plug in those values and it would make it equal to 0. The second picture, now bless you, I only have one spot and it just touches on the vertex. So this would just have one answer, and that would just be 6. What would you write down for your zeros for this last graph? None. I don't have anything. Okay, doesn't touch the x-axis. Now, here, we're going to get into this a little later in this unit, but I'm going to write down no real solution. We are going to talk about imaginary solutions. That's later in the unit. There are 2 solutions to that, actually, but they're in imaginary land. We'll talk about that next week. So for the moment, if your graph does not cross or touch the x-axis, you don't have a real solution. Okay, now I am going to have us just a little review to graph these by reminding what we did in our last unit. So instead of me giving you the graph, I'm going to give you the equation. So we're going to graph the related quadratic. The related quadratic would literally just be, you don't need to write this down, but y equals x squared minus 4x minus 5. I'm just going to graph that and then see where, just like in the last couple questions, it touches or crosses the x-axis. This is in standard form. So whenever you're graphing a parabola, 2 key things. You want to find the vertex, and then you want to tell me what pattern you might want to use to get more points. So anybody remember how to find the vertex if we have the equation in standard form? Yes. Okay. And I promise you guys, I was literally working with somebody on this in pre-calc and calculus today. And we just used negative b over 2a. And I was like, oh yes, we're doing this in my other class. We're going to do negative b over 2a, and then whatever you get for that, you're going to plug that back in like a Glade air freshener to get the y-coordinate. Okay, so what would we have here? So negative b over 2a would actually be positive 4 over 2 times 1, which is just going to give us 2. Okay, and then I'm just going to grab my calculator. So in that equation, everywhere I see an x, we're just going to replace it with 2. So we'd have 2 squared minus 4 times 2, and then minus 5. So it would just give me negative 9. And then I've got my vertex. Okay, now, if I have my vertex, All right, sorry, I don't think I'm going to get this on the screen at the same time. I'll scooch this up because it's going to be the very bottom of the graph. So if 2, -9 is my vertex, how would I find another point? Or how would I find more points? This is just going to be 1, 3, 5. The A value here is 1, so that's just the 1, 3, 5 basic pattern. Okay, now ultimately what we need to figure out is where does it touch or cross the x-axis. If I am asking you to do this by hand, it will cross or touch in a nice place. Okay, so just go over 1, up 1, over 1, up 3, and then if you go over 1, up 5, you should be on the x-axis. Can anybody tell me what the zeros are here? What'd you get? Should be -1 and +5. Okay, is anybody, oh, not on the screen, sorry, -1, +5. Is anybody having a question? Okay, now I got another one here real quick. So in the middle there, same kind of a concept. This is also in standard form. It doesn't have a constant term, so it's -x² plus 6x. So for this one, my negative b over 2a would be -6 over 2 times -1. So that would give me -6 over -2. So that's going to end up being +3. Okay, now just to tell you guys this as a little reminder, if I start out with -x², if I want to use my calculator, plug this in, make sure you have the negative symbol out in front because we are not squaring -3 here. It's like -1 times what I plug in. So I'm going to leave that negative out in front. That should cause that first term to be negative. That turns your graph upside down. So I'm going to do negative. We're plugging in 3. So -3 squared. And then plus 6 times 3. And I got 9. So then this vertex, 3, 9. And unlike the previous question, this will be at the very top of the graph. What would you do to get more points for this particular problem? We're not going to go up, right? Because there's no graph there. Yes. So your A value here is -1. That affects the pattern. That's just going to cause you to go upside down. So just over 1, down 1. Over 1, down 3. And then over 1, down 5 should put you right on the x-axis. Okay, so you guys see this is going through at 0 and 6. Is anybody having a question at the moment? Okay, just for 1 second, I want to go back and I just want to relate this to what we've been doing with the factoring, see if this makes sense to you guys. So this first one, like if I factored it, right? Factors of -5 that add up to -4, it'd be x minus 5, x plus 1. That'd be the factored form there, right? And my two answers would be 5 and -1. Look where that's crossing the graph, right? It's exactly the same thing. I just factored it real quick. If you factored this guy right here, I would take out a -x, and then I would have x minus 6. And if you look at where this one touches the graph, this would be 0 here, this would be 6 here. That's exactly where I'm touching the graph on the x-axis. So that can relate back to what we were doing yesterday. Now, I'm not going to do this on this question because I'd have to FOIL this out, and I'm not doing that. So, vertex form is what I have for this last one. How would you graph if you have vertex form instead of standard form like I had these other two? Like, how would I find the vertex here? Exactly. It's just going to be your opposite copy. So much faster to find the vertex in vertex form because you can see it. It's what sets the parentheses equal to 0. That's your x-coordinate. That's where it switches from one side of the parabola to the other. And then copy whatever's on the outside. That's your y-coordinate. And what would my pattern for graphing this be? Or is it going to be 1, 3, 5? Because, good. That A value is out in front in that vertex form. That does affect your pattern. So this is going to stretch the graph, make it more narrow. So if A is 2, that just changes up. Take that 1, 3, 5, multiply it by 2. So it would be 2, 6, 10. You're really not going to get 10 on the graph here, but we should be able to get the 2 and the 6. So if I come over here, I'm going to go 5, -8, and then I'm going to go over 1, up 2. It's always over 1 and then up or down the pattern. From there, over 1, up 6, and that should put you right on the x-axis there. All right, really, your parabola doesn't have to be perfect or anything. I'm really just looking for those x values where you touch across the x-axis. Here it's going to be 3 and 7. Okay, is anybody having a question so far? Okay, I'm going to actually show you how to do this next one on the graphing calculator just to make it go a little bit faster, but I have to also show you how to do this algebraically. So this is actually solving a system. Both of the equations in my system here are going to be parabolas, and we don't have to use the graph. I want to show you how to do this on the graphing calculator, but if you want to sketch a picture, you can. So I'm going to show you how to graph first, and then I'm going to show you how to do this. Just if we didn't have a graph, we didn't have our graphing calculator, how would I do it algebraically? Okay, so if you guys want to grab your calculator real quick, we are going to type these two equations into y equals. So, bless you. I'm just going to hit my y equals button at the top. You might already have something in here. I don't know. Actually, look, do me one favor before we start. Hit the zoom button on your calculator, which is in the very middle, that top row, and just hit number 6, which is just going to make the graph from -10 to 10, so we can see this okay. All right, so just do that real quick, because somebody may have messed with your settings last period if you're borrowing one of mine. All right, now, y equals. I'm going to type this in. Now, I have negative x minus 1 squared. You don't have to FOIL this out. You can type it in right like that. Just use your parenthesis keys. Just make sure, use the negative. Do not use the subtraction sign. The calculator does not like that. And then I'm going to do x, and then I am going to use the subtraction sign, minus 1. Just close the parentheses, and then that little squared button should be kind of diagonal from the 7. And then just a +2. And I'm just going to use my arrow key to go down to the next line. And I'm going to type x squared plus 4x minus 3. Okay, now once you're there, if you want to hit your graph button to see what it looks like, but I'm actually going to go to a menu that will tell us exactly what the answers are. So I'm going to show you how to do that in case they're not nice numbers. They will be nice numbers for this example, but just in case they're not. Okay, so I haven't been writing this down. So y equals, you're going to type your equations. After you've got them, you can hit the graph button and look at it if you want, but you don't even have to do that. What I'm going to use here, I'm going to hit second, and then that trace button. That's the calculate menu. So I'm going to hit second trace. If I'm solving the system, what am I looking for? Intersection. So we're just going to put, I'm just going to arrow down to that, or you can type the number 5. If you arrow down to it, I think you have to hit enter. So number 5 says intersect. And I'm going to hit enter on mine. Now, it takes you back to the screen automatically. Now, here's the deal. There's like a little cursor, right? So there's 2 different places this intersects, so I'm going to have to do this twice, but I'm going to go to the one on the far left first. I'm going to scooch this up just a little bit. Don't use the up and down keys. That will just switch you from one graph to the other. You want to use the left and right keys. I'm literally just going to hold this down until it gets close to one of the intersections of those 2 parabolas. It doesn't have to be exact, just close to it. Once you're there, you're going to hit enter 3 times, just 1, 2, 3, and then it will display the intersection across the bottom, which should be -2, -7. Now, unfortunately, I can't just find the other intersection. You have to repeat the process. So I'm just going to repeat that process to find the other place these 2 guys have in common. So I'm just going to, again, just second trace. I want the intersection, so number 5. Hit enter or just type number 5. Should take you back to that screen. Now, it'll be where we just were. So I'm just going to hold down the right arrow key until I get closer to the other place they intersect. Once I'm just near that, just enter 3 times. And then it should hone right in on it. The other intersection is the point 1, 2. If it's not a nice number, just round it to 2 decimal places, the nearest hundredth, and that would be good. Okay, so those are my 2 answers. Okay, now pretend I didn't have my graphing calculator. How would you solve this just using algebra? If I gave you a system of give you the system, how would you solve this algebraically? Does anybody remember? Like from our systems unit, what would you do? Yeah. I would set them equal to each other for sure. Okay, so they're both equal to y, right? So this is a little bit more complicated than what we did in our systems unit because we weren't working with quadratics yet, but this is equal to y, so I'm just going to substitute that in. Okay, so I'm going to try and write kind of smaller here. So it'd be x minus 1 squared plus 2. They're both equal to y, so they have to both be equal to each other. Now, the one part that is tricky here for that one that's in vertex form, I do need to FOIL that out. Okay, now I'm just going to kind of cheat, but what I'm doing is I'm doing x minus 1 times x minus 1. Oh my gosh, I just wrote a plus. Sorry, that's a minus. Minus, because I'm just multiplying it by itself. Okay, now, if you FOIL this out, you should get x squared. Now you get minus x minus another x, so it'll be minus 2x, just combining like terms just to save some space. And then negative 1 times negative 1 will be positive 1. And I'm just bringing down the rest of this. So this was plus 2, and then I had x squared plus 4x minus 3. Okay, now from this point, I had a little negative out in front of those parentheses, so when you distribute that, it's just going to change everybody's sign. So it'll be negative x squared plus 2x minus 1 plus 2, and then I've got the x squared plus 4x minus 3. And I'm just not going to use the graph, so don't worry about that. Now, if I just combine my like terms just real quick, negative 1 plus 2 would give me 1. This would be x squared plus 4x minus 3. Okay, any idea what I should do from there? Don't everyone volunteer at once. If I'm trying to solve a quadratic, what should I do? Get it equal to 0. Okay, now, the other thing you want to do, I would really recommend to make it easier, keep your squared term positive. So if I'm going to keep my squared term positive, what I'm going to do, I'm going to add this x squared to the other side. That'll keep my squared term positive. The linear term, the constant, doesn't matter. So I'm going to move the 2x and I'm going to move the 1. So the 2x I'm going to subtract, the 1 I'm also going to subtract. Then what I would be left with is 0. Now this becomes 2x squared, and then it's going to be plus 2x minus 4. Okay, what would you do here? Does everybody have anything in common? Yeah, let's get rid of this garbage too. This is making all these terms bigger than they need to be. So you can divide everything by 2. I've got an equation here, including that 0. This is going to stay 0. Then I got x squared just plus x and then minus 2. Okay, now I'm going to factor this real quick. Can you guys think of two numbers? I want to multiply these two numbers to get negative 2, add to get 1. 2, negative 1, so x plus 2, x minus 1. Now, my actual answers, right, would be negative 2 and positive 1. Okay, now, if you guys look back, and I know we solved this on the graph just a second ago, these are just the two x values, and that throws people off sometimes. So these are just, I have actually two solutions here. These are the x values. So to answer the question, it's the point that they have in common. You have to plug these in to the original system. Like if I didn't already know the answer to the question, you could go back either one of these equations, plug negative 2 in for x, also plug in 1 for x, and then find the y value. So keep that in mind. So if you have that, you'd have negative 2. If you plug it back in, you'd get negative 7 for y. And if you had 1, you plug in 2. We saw that on the graph. But those are just the x values when you get those solutions if you do this algebraically. Okay, is anybody having a question? Okay, now I'm going to show you a couple things on the calculator with this last example. There is a little equation, and it kind of copied weird here, but this equation is what we're going to type into the calculator in 1 second here. But I'm going to show you how to do a couple things actually with this problem on the calculator. So this is a beautiful little picture of a frog. It's really cool on my computer file because it's in color, but it's not cool here because it's boring and gray. Anyway, so the frog jumps in the air and eventually gravity is going to pull it back down. Across the x-axis, if you read the directions here, the x-axis is the distance that the frog travels, and the y-axis is the height for the frog. Okay, the first question just says how high did the frog jump and how far did the frog jump? Okay, there's a couple ways to do the second part of this question, but there's really only one way to do the first part of the question. If I'm asking you how high in the air this frog is, how would you figure that out? What is the height that the frog gets up to as he's doing his jump? Exactly. Okay, so this is a bad sketch, but this is just going to be your distance traveled here, but at that vertex, the y-coordinate is going to be the height. Okay, now, you can, if you want to, just do negative b over 2a and plug in negative b over 2a. You could totally do it that way if you want to. I want to show you how to find this on the calculator. This is not going to be a nice value for one of the answers, so I just want to show you how to do this on the calculator. All right, so I'm going to grab this. And in y equals, let me just clear out the ones we were just working on. And I'm going to type this equation that they got in the picture, so it does have a little negative in front of it. It's 0.029 x squared, and then plus 0.59 x. It's a little bit hard to read on the copy, but you should have negative. Make sure you don't use the subtraction key, use the negative key. 0.029 x squared plus 0.59 x. Okay, now this is a weird equation. So I'm just going to hit graph and see what's going on here. And you guys can kind of see this is not really displaying kind of what they have in the picture. So I'm just going to show you how to mess around with the window real quick. So I don't really need negative x values here. I'm going to hit the window button. And just so I can see the x and y axis, I'm just going to make the x minimum, so the smallest x value, I'm just going to make that -1. Okay, my graph right now was at 10. It was not going far enough over. So let me make it like, I don't know, maybe I'm just going to make a number. We can always go back and do it. I'm going to try 25. And then, again, I don't need negative y values here. We're not going to have a negative height. So I am going to put this at -1 for the minimum. That way I can see the x and y axis. And then I'll just leave the height alone and see if that looks good. So just change the x min to -1, the max to 25. Leave the scale alone. That just tells you it goes by ones. And then the y minimum, I made -1, the maximum 10. Just hit your graph, and then that looks a little bit better in terms of being able to see the picture. I could make the height a little bit smaller, but this is good. Okay, now we're going to find the vertex, right? So I'm just going to show you how to do that real quick. The calculator will do this for you. It's actually that same menu. If you hit second trace, which is the calculate menu, and you want to find the vertex for this graph, which one of these do you think you're going to pick? Now, the 0, actually, and I'll show you how to do this too, the 0 would be here. What do I want to pick if I'm trying to find the vertex? Yeah, maximum. If the graph was going the other direction, we could put minimum. But yeah, if you want a maximum or minimum, remember that's just the vertex. So I'm just going to pick number 4. We'll do the 0 in a second. So I'm going to pick number 4, which is the maximum. Okay, either type 4, and that should take you back right to the graph, or if you arrow down to it, you have to hit enter, and that takes you back to the graph. I don't think we've done anything like this so far on any of the graphing calculator activities, so we're going to try this. This is weird. So across the bottom, you should see it say left bound. All right. What you're going to do, you got to move that cursor, and sometimes you have to and sometimes you don't. It depends. Just come somewhere. I'm just going to use the left arrow key. I'm just holding this down. Just come somewhere on the left side. Just somewhere on the left side of that vertex, and then you're going to hit enter. Then across the bottom, it's going to say right bound. And all you're going to do is just move that little cursor anywhere on the right side. I'm just holding down my little right arrow key. And it's going slow, sorry. Just anywhere on the right side of where that vertex is. Now, depending on the type of calculator you have, it might pop up two vertical lines. You'll see what it's saying is look between these two vertical lines for the maximum. That's what it's telling the calculator to do. Now, it will, I don't know why this is, but it says guess across the bottom. Well, we don't want to guess. That's the whole purpose of using this. We want the calculator to just tell us the answer. So just where it says that, just hit enter, and it should hone that point right in on the vertex. Okay, now, if it's a nasty number, just round to the nearest hundredth. So for this question, I'm going to go 10.17. Now, the y-coordinate's like 3.00, and then it's got some other stuff, but I could just go ahead and round that to 3. So that's going to be my vertex. Now, the way the equation's set up, this is your distance, and the 3 is your height. So the actual answer to this question would just be, it's in feet, so it would be 3 feet. Okay, now I'm going to show you one more thing. And there's two ways you could actually do this with some symmetry with the vertex, but I'm going to show you how to do it with the 0 as well. So, how far did the frog jump? That would be this point right here. Yes? Okay, so that is just a 0, right? My other one would be the actual origin, but how far the frog jumps is going to be that point right there. So let me show you how to find that on the calculator. I'm going to actually go back to that same menu. I'm going to hit second trace. And from this one, I want the 0. So number 2 says 0. So you can type the number 2 or you can arrow down to it and hit enter. All right, now, this is a little bit weird. When I'm on the left side, so I'm approaching the 0 from the left, right? I'm just getting a little closer to this. In this particular problem, the left side is just going to be above the x-axis. All right, so the left side just somewhere above the x-axis. Hit enter. Now, I need to go past the 0 to be on the right side of it. So for this question on the 0 there, I'm going to be underneath the x-axis, just somewhere underneath the x-axis. Hit enter. And again, it'll pop up those vertical lines. And it's saying to the calculator, look between these two places for where I touch or cross the x-axis. And it says guess again. Just hit enter. And you should get 20 point, like about 3.4 if I round to the nearest hundredth. And this would be in feet for this problem. It's a very similar process to finding the vertex. It's just left side, right side of a 0. You're either going to be above and below. If the graph turns the other direction, the left side will be above and the right side will be below. So just keep that in mind. Okay, is anybody having a question? Okay, now just I'm going to write this real quick. So my domain goes from 0, and then the frog jumps that 20.34. So we start, we haven't taken any distance, and then we jump, and then we land. And for the range, the maximum height the frog reached was 3. So I would just say 0 to 3. We don't want a negative height. Is anybody having a question?